Your legs are moving right now, but something far stranger is happening deep inside your muscles at this exact moment. Inside every single muscle cell, there are thousands of microscopic structures working furiously, and you have never noticed them. They are called mitochondria, and they are so small no human eye could ever hope to see one. Yet these tiny structures control something enormous, something that decides whether you feel energized or completely drained every day. They produce energy, the actual energy that powers every heartbeat, every breath, and every single step you take. Without them functioning properly, your muscles would stop moving within seconds, not minutes, seconds. The moment you begin walking, an invisible chain reaction fires off instantly inside your cells without you noticing. Your muscles send urgent signals downward, demanding fuel immediately so they can keep contracting again and again. Mitochondria respond instantly, accelerating chemical reactions that most people will never learn about in their entire lives. Nutrients rush into metabolic pathways while oxygen combines with them to create something called ATP. ATP is the actual currency of energy, the thing your muscles spend every single time they contract. Here is the part almost nobody tells you. Mitochondria are not passive. They are constantly adapting. They listen closely to the signals your body sends them, and they change based on what they hear. When movement becomes regular, mitochondria start increasing their activity and working with far greater efficiency. They begin deciding something important, whether your body burns mostly sugar or finally starts tapping into fat. This means every single walk you take is quietly waking something up deep inside your muscles. Your mitochondria begin adjusting themselves, preparing for steady demand instead of staying dormant and inactive. Over time, if walking becomes consistent, these tiny structures multiply and become dramatically more powerful. They get stronger, they get more numerous, and they get better at converting fat into usable fuel. Walking looks simple from the outside, but inside your body, it sends a life-changing biological signal. Now here is where most people get the entire story completely and painfully wrong. When people feel exhausted constantly or notice stubborn fat that refuses to disappear, they blame themselves. They assume their metabolism is broken, that something inside their body has permanently stopped working correctly. A quiet, painful thought forms. Something must be wrong with me, something I cannot fix. But in most cases, the real problem is not damage, it is simply underused mitochondria. Mitochondria respond directly to demand, and when muscles stay inactive, their energy production quietly slows down. This is not damage happening inside you. This is adaptation, your body adjusting to your lifestyle. If someone sits for hours daily, their muscles barely ask for energy, so mitochondria scale back. Over time, this reduced demand makes energy production feel sluggish, tired, and frustratingly inefficient. Even small physical efforts start feeling exhausting, and fat burning slows because it is rarely required. But none of this means mitochondria are broken permanently. They have simply adapted downward. Here is the encouraging truth. Mitochondria can adapt upward again just as easily as they adapted down. When muscles start moving regularly again, energy demand rises, and mitochondria immediately notice the change. They begin producing ATP faster, processing fuel more efficiently, and multiplying to meet new demand. This is one of biology's most remarkable features. Your cells are constantly learning from your behavior. Walking sends one of the clearest signals possible, telling mitochondria that energy production matters again now.
Because walking is gentle, it can be repeated daily without overwhelming a system trying to recover. So if your energy feels low, it likely does not mean something inside you is broken. it probably means your mitochondria simply have not been asked to work hard recently. Walking begins changing that signal immediately, and repeated signals eventually create lasting biological transformation inside you. Now, let's destroy another myth, the idea that only intense, exhausting workouts can fix your metabolism. Everywhere you look, people insist you must push hard, sweat heavily, and feel completely wrecked afterward. Exhaustion gets treated like proof that something good is happening deep inside your struggling body. But the actual biology of mitochondria tells a completely different and far more interesting story. Mitochondria rely on oxidative metabolism, a process using oxygen to convert fuel into usable ATP energy. This process works best under steady, moderate demand, not under extreme, overwhelming physical stress. Under these balanced conditions, mitochondria efficiently produce large amounts of energy while also burning stored fat. Extremely intense exercise creates a different, more chaotic situation inside your desperately struggling muscle cells. When energy is needed faster than mitochondria can supply it, your body switches to emergency pathways. These pathways generate quick energy, but they are inefficient and create fatigue-inducing metabolic byproducts almost instantly. This does not mean intense training is bad, it simply is not ideal for training mitochondria. Walking, meanwhile, creates exactly the environment mitochondria genuinely prefer for long-term metabolic improvement. During a walk, muscles need energy continuously, but never explosively, keeping oxygen delivery calm and stable. This allows mitochondria to run smoothly, gradually processing fat and glucose through longer, more efficient pathways. This steady demand lets mitochondria practice the exact processes responsible for real metabolic efficiency improvements. Over time, enzymes involved in fat processing become significantly more active and increasingly efficient overall. In other words, walking quietly and consistently trains your mitochondria without you even realizing it. Each step becomes a small request, and mitochondria respond by improving how they generate usable energy. As this system improves, your body relies less on rapid glucose and more on steady fat-burning metabolism. Fat metabolism becomes more active, energy becomes more stable, and muscles experience far less metabolic stress. So, while intense workouts feel powerful, quiet, repeated walking often trains your metabolism more effectively long-term. But mitochondria never work alone. Hormones circulating through your blood heavily influence which fuel they use. One hormone in particular controls almost everything about whether you burn sugar or finally burn fat. That hormone is insulin, released by your pancreas whenever blood sugar rises after eating something. Its main job is moving glucose from your bloodstream into cells for immediate or stored use. But insulin does something else too. It sends powerful instructions about how your body handles energy. When insulin rises, your body receives a clear message: energy is abundant, so store it immediately. Mitochondria prioritize glucose because it is suddenly abundant and effortlessly available throughout your entire bloodstream. At the same time, insulin tells fat cells to lock down and refuse to release stored fat. This means fewer fatty acids circulate, and mitochondria lose access to fat as usable fuel. This system made sense historically when food was scarce and storing energy meant surviving longer. But modern eating patterns have changed everything. Meals and snacks constantly keep insulin elevated throughout entire days.
When insulin stays high constantly, fat cells remain locked and mitochondria keep burning only glucose repeatedly. Walking begins changing this hormonal environment almost immediately in ways most people never fully realize. When you walk, muscles contract repeatedly and pull glucose directly from your bloodstream without needing insulin. This allows blood sugar to stabilize naturally, requiring far less insulin than your body normally produces. Over time, this reduces insulin spikes after meals, sending fat cells a completely different message. The storage signal weakens, fatty acids leave storage and enter your bloodstream ready to be used.
Once fatty acids are circulating, mitochondria finally gain access to a massive, previously unavailable fuel supply. This is one of the quietest, most powerful ways walking transforms your metabolism from the inside out. To understand this deeper, we need to travel further inside the cell where energy is truly created. Deep inside muscle cells, mitochondria function like miniature laboratories, converting raw fuel into usable, powerful energy. They receive molecules from your bloodstream and transform them into ATP, the battery powering every movement. When you start walking, ATP demand increases instantly, and muscle fibers begin contracting in rapid sequence. As ATP gets used quickly, your cells signal mitochondria that significantly more energy production is required. Mitochondria respond by accelerating their internal machinery, processing fuel molecules through carefully coordinated biochemical reactions. Glucose and fatty acids both enter this system, but they travel completely different metabolic pathways first. Glucose breaks into smaller molecules, which travel into mitochondria and enter a powerful energy-extracting cycle. Fatty acids follow another route entirely, entering through what scientists call the carnitine shuttle system. Once inside, they undergo beta oxidation, breaking down gradually into usable energy-producing fragments for your muscles. Eventually, both pathways converge into something called the Krebs cycle, deep inside your mitochondria. From there, high-energy electrons move into the electron transport chain, one of biology's most efficient systems. This chain uses oxygen to capture and convert energy into ATP with remarkable, almost unbelievable efficiency. Walking creates perfect conditions for this system, keeping oxygen delivery steady and completely uninterrupted throughout movement. Because of this, mitochondria run the electron transport chain smoothly without being forced into emergency mode. But something even more powerful begins happening if walking becomes a truly consistent, unbreakable daily habit. Genes responsible for mitochondrial growth activate, and muscle cells begin producing brand new mitochondria entirely. This process is called mitochondrial biogenesis, and it dramatically expands your body's total energy-producing capacity. More mitochondria means more ATP and more capacity to process fat efficiently during everyday activity. Each new mitochondrion becomes another tiny power station, expanding your cell's ability to generate energy. This is one major reason walking gradually improves endurance, stabilizes energy, and supports long-term fat metabolism. After several weeks of consistent walking, a quiet turning point begins forming deep inside your cells. From the outside, nothing dramatic seems to change. Your walks simply start feeling noticeably easier somehow. But internally, mitochondria are beginning to behave completely differently than they did just weeks earlier. At first, mitochondria relied heavily on glucose simply because it was the most familiar fuel. But as walking repeats daily, mitochondrial metabolism gradually shifts towards something far more sustainable and efficient.
Muscle cells increase mitochondrial numbers, while existing mitochondria improve their ability to process oxygen and fuel. Enzymes involved in oxidative metabolism become more active, converting nutrients into ATP with impressive new efficiency. As this happens, fatty acids enter mitochondria more easily, and beta oxidation pathways increase their overall activity. Gradually, mitochondria begin producing more energy from fat instead of relying almost entirely on glucose. This shift creates balance, giving your muscles something scientists call true metabolic flexibility for the first time. Metabolic flexibility means your body smoothly switches fuel sources depending on exactly what is available. When glucose is abundant, mitochondria use glucose. When fat is available, they shift toward fat instead. Walking repeatedly trains this flexibility because it provides enough oxygen for efficient fat processing constantly.
Over time, energy levels stabilize throughout the day, and sudden crashes become noticeably less frequent overall. Muscles become more efficient at producing ATP, and fat contributes more consistently to daily energy needs. But here is something painfully important. Many people never reach this powerful mitochondrial turning point at all. Not because their mitochondria cannot adapt, but because the required signals never become consistent enough over time. Many people start walking with high hopes, expecting dramatic transformation within just a few short days. For a while, movement feels exciting, and the idea of changing metabolism feels genuinely encouraging. But after weeks pass, people wonder why nothing dramatic seems to be happening inside their body. At that point, it becomes tempting to assume walking simply does not work for them personally. But in most cases, the real issue is inconsistent signals, not a fundamental failure of biology. Mitochondria adapt based on repeated demand, and occasional walking sends weak, confusing, and inconsistent instructions. One day there's demand, then several days pass with almost no activity happening at all. Without repetition, mitochondrial adaptation slows dramatically, leaving people frustrated and convinced that walking simply failed them. Frequent eating interferes too, because constant snacking keeps insulin elevated and blocks fat from being released. When insulin stays high, cells rely heavily on glucose, and mitochondria rarely practice burning fat instead. Chronic stress interferes as well, since cortisol pushes the liver to release even more glucose constantly. This extra glucose becomes an easy fuel source, again discouraging mitochondria to adapt toward fat metabolism. Poor sleep disrupts hormonal rhythms too, reducing insulin sensitivity and destabilizing your body's natural energy regulation. Under these conditions, mitochondria may struggle to fully adapt, even when walking happens somewhat regularly. All these factors compete with walking's powerful signal, sometimes canceling out the very progress you're building. But here's the reassuring truth. Mitochondria do not require perfection, they simply require honest consistency. Once your body sends repeated signals that steady energy production matters, mitochondria respond reliably every single time. And once that adaptation finally begins, something genuinely reassuring starts happening deep inside your entire body. Improving metabolism does not require extreme workouts, complicated routines, or expensive equipment sitting in your home. The real requirement is remarkably simple. Your mitochondria just need one clear, repeated, honest signal. Every walk you take asks your muscles for ATP, and that request travels straight into your cells. At first, mitochondria simply work slightly harder to keep pace with your steady, comfortable movement. But once walking becomes consistent, something far more powerful begins happening deep inside those tiny structures.
Genetic pathways activate, encouraging mitochondrial growth, efficiency, and long-term metabolic transformation throughout your entire body. Existing mitochondria improve at processing oxygen and fuel, while new mitochondria begin forming to meet demand. Each new mitochondrium adds another power station, making energy production noticeably smoother and more sustainable overall. Instead of relying on quick glucose bursts, cells shift toward oxidative metabolism, unlocking stored fat reserves. As mitochondria grow stronger and multiply, they process fatty acids far more effectively than before. Your body begins accessing stored fat more easily, and walking itself starts feeling noticeably easier too. This transformation does not require intensity. Mitochondria respond best to steady, comfortable, and repeated activity instead. Walking provides exactly that signal, and the pace never has to be extraordinary or exhausting whatsoever. What matters most is consistency, the steady, reliable message sent to your cells day after day. A regular walking habit quietly trains the cellular machinery responsible for producing the energy that sustains you. Day after day, your muscles ask, and day after day, your mitochondria respond by growing stronger. Over time, this strengthens your entire metabolic system, stabilizing energy, improving efficiency, and activating fat metabolism. What looks like a simple walk outside is actually a powerful training session happening deep within you. Your mitochondria are listening right now, waiting patiently for the next signal you decide to send them.